Hi everyone, so welcome for a new repair video, diagnosis and repair video. Today we're working on an A1706, which is a MacBook Pro from 2016 or 2017. Board number is 820000923. And the problem with this MacBook is that it's not powering on. I already took the board out because I did make some measurements before starting the video, which led me to believe that I do need to take the board out. But at first, the first things I did was try to measure what I could measure on the board that's inside the housing, which means that I'm going to connect the power to this port, this USB-C port here, because this USB-C port here is powering this USB-C controller, which is on top of the board. And what are we getting? Let me open this camera. So it's drawing 140 milliamps and it is staying at 5 volts. So it's not negotiating the 20 volts, which means that the CD3215 circuit, so the powering up conditions for the CD3215s, for the 4 CD3215s are not satisfied. Something is abnormal in their boot up process. Of course, I did try all the ports and they all gave me the same behavior, meaning that no port is behaving differently from the other ones, meaning that I can use either one to do my diagnosis. So therefore I'm using this one because this one is connected here and this is directly accessible when the board is inside the housing. We're gonna make some measurements. Let me turn this off. So what do we want to measure? First, so when I'm connecting to the bottom port here, this is the power coming in from the USB-C charger or from the power supply. This is the CD3215. So PP 20 volts, USB-C, XB, VBus, is the 5 volts coming in from the charger. Once the CD3215 gets power, it is supposed to turn on the 3V3 LDO and the 1V8 LDO-A and LDO-D, and once these are turned on, it takes control of this MOSFET Q3200, which is right there, and it passes, the MOSFET closes and passes the 5 volts to here, and it becomes PPDC and G3 hot. So this is the first thing I want to measure, is if this first stage of powering on is working. So let's go under the microscope. Or let's first see. So this is the thing that I want to measure, PPDC and G3 hot, to know if this MOSFET is closing as it should. So there we go. Let me take off these glasses. Yeah, you should be able to see the multimeter. And so as we can see, we're getting 5 volts here, meaning that the 3 LDOs are working, the MOSFET is working, the CD3215 is controlling the MOSFET, everything is working as it should at this point. The next power supply that the CD3215 wants in order to work is PP3V3 G3 hot. Yeah, on this board it's called PP3V3 G3 hot. So I should be able to measure it here. And this is supposed to wake up all the CD3215s. So this one is awakened by the charger, and then it will pass on the 5 volts, which will then go to another chip that creates this PP3V3 G3 hot, which is supposed to wake up all the CE3215s. Let's see if we have it. So we're supposed to measure it right there. And we're getting only 2.4 volts instead of 3V3, which is most probably why the board is not turning on. Of course, we didn't find the cause of the problem, but the cause of the problem is causing this 3V 3 to not happen, and then the CE3215s cannot turn on, and of course then the board cannot turn on. So we have to figure out why. The first thing to check is whether the line is shorted. So I just disconnected it from power, and I'm going to put the multimeter in diode mode and take the measurement here. We're getting 325. So I don't know the values by heart, but 325 seems very normal to me. At least there's no short here. Okay, there's no short. So now who is creating PP3V3 G3 hots? It is this guy over here, U6903. And we do know that it's creating something, which is 2.4, but it's not creating what it should be creating. So what could be wrong? First, we need to know if it's getting power. So it should be getting here PPV in G3 hot, P3V3 G3 hot, which is coming, so here it says from DC in, because right now PP bus is not present, because PP bus happens much later. It happens after we get the 20 volts from the charger. So we need to look at this. We're supposed to get here 5 volts PPDC and G3 hot charger. And it's going through a diode. So after the diode is going to tax maybe 100 or 200 millivolts. So here after the diode, we're supposed to get maybe something like 4.8 volts. And then we also need to check if the enable signal is present. So this is the diode. This is the 5 volts that we're supposed to get, and the enable is here. So let's make sure we have these. Let me reconnect it to power and look for my U6903, which is here. Well, you can see that there's a little bit of flux here. That is because I soldered a wire to inject voltage at some point in my diagnosis process. So the diode, sorry, let me put in volt mode. We're getting 4.5 volts here, while I was expecting normally 4.8. So this is kind of low. And the enable signal here, we're getting 5 volts. So it is getting power, even though this power is kind of low, and it is also getting its enable signal. The output is still 2.4, 2.5 volts. So at this point, there are various possibilities. The chip could be defective. The chip could be working abnormally because we're getting only 4.5 volts instead of 4.8. Even though I don't believe that such a small difference could make such a big difference on the output. It could be a problem with the feedback loop because this chip, how does it know what it's supposed to output? Well, it knows it's supposed to output 3.3, but what it does is here there's this feedback loop, which is like the chip checks what it's outputting, and if it's not outputting the right value, the right voltage, then it will adjust the way it's working in order to get 3.3. So maybe if the feedback loop has a problem, so maybe one of those resistors or this capacitor or one of these resistors, if one of those have a problem, feedback could be screwed, and since the chip is getting wrong feedback, then it's not outputting as it should. It could also be that this how's it called? This coupling capacitor is not working, is defective. That's a possibility. Or it could be that something on the output is pulling the voltage low. So these are our various possibilities, and we can explore them either way. But what I think is the most reasonable thing to do is, well, you know, we saw that the board is pulling 140 milliamps, so there's power going somewhere. And for me, the logical thing to do is to pull the thermal camera and see where that power is going. So this is what I want to do. Let me see if I can get the thermal camera on. Okay. Okay. Oh, so we saw something getting hot here. Use these. So this here is getting hot. If I want the exact temperature, I can, here we're getting 45 degrees, which is not which is abnormal. This chip here is the SMC. And we're also getting that this chip is getting hot. And what is this chip? This is my U6903. Let me put the macro lens so we get a better view. So here, oh no, this is, excuse me, this is the diode, and this is U6903. The diode is also getting quite hot at 50 degrees. And then the U6903 is right here. Let me remove this. Okay. So these are the things that are drawing power. The fact that U6903 and the diode are getting hot, this is kind of expected because, well, I mean, this is kind of expected if something is pulling the voltage low. And this is, and I believe this is what's happening. The SMC here, this guy at this point is not supposed to get that hot. And this is why I believe there might be a problem with the SMC, because the U6903, it's a power supply. It gets hot because it's working. It's trying to supply power. It's trying to supply 3.3 volt, but it's not able to do it. maybe because the SMC is defective. So I'm not worried about U6903 getting hot. However, I am worried about the SMC getting hot because the SMC is not a power supply. So it's not supplying power to anything except itself, and it shouldn't be getting hot at 50 or 50, 40, 45 degrees. So I'm more inclined to think that there's a problem with the SMC or maybe the LDOs it's creating for itself. So let's go to the board view software and find the SMC. So it's this guy here. There we go. So it's powered by PP3v3 G3 hot SMC iSense, which is actually the same as PP3v3 G3 hot. And it's also powered by PP3v0 G3 hot AVREF SMC. It's also creating for itself this LDO PP1v2 G3 hot SMC VDDC. What do I want to do at this point in order to confirm that the SMC is a problem or not? What I would want to do logically is to just remove it. Remove it and see if after removing it, we're getting PP3v3 G3 hot at a normal value of 3.3 volts. The problem is that removing the SMC is not a trivial chip. If I remove it, I could damage it, so I would like to introduce as little uncertainty as possible. So what I could do rather than removing it is cut power to it. Because if we look again at the schematic, power is coming here through L5001, which is powering the SMC and also SMC wake L. It's also waking it up. So the SMC is also getting how do I call it? An enable signal, which is buff SMC reset L. So in order to turn off the SMC, which would be the same as removing it, I believe that I could just remove L5001 or cut this signal to it, which would turn it off and make it look as if it's not here. And this to me looks less traumatic than removing the SMC. So let's see where this, if I have a way to remove this. So this comes from here. So, well, so this is no stuff. Yeah, so no. Apparently it says that this thing is not present. So I'd rather just remove the... I'm hoping that if I remove the inductor, it will be the same as disconnect as removing the SMC, and then we'll see if power gets normal again. if 3v3 G3 hot is coming again. So it's on the other side of the board. It is right there. Where's my, yeah. This is my L5001. I'm going to check if it's defective or not. So no, it seems to be working. Well, I'm changing the nozzle on my hot air gun in order to get one that has the right size for this chip, for this component. There you go. So I just disconnected from the board, and I'm gonna wait a few seconds for the board to cool down and connect the board to power again to see if something changed. And so now that the board is connected to power, so we're still drawing 140 milliamps. So, okay. So what I'm doing is not certain at all. I'm at the same time, I'm learning new stuff. So apparently this is not enough to prevent the SMC from working. Okay. So I'm gonna put back the inductor. Or let's see, what are the other power source? I said the other power source is, so the other power source is this PP3V0 G3 hot AV ref SMC. Do I have a way to disconnect it? So in order to disconnect it, I would have to remove this chip, which I don't really want to do, because then I would have to reball it. Or I could check. Do I remove this chip or not? TTT. Let me think. Uh, I don't really want to. I mean, removing an inductor is not the problem, but removing this chip is kind of annoying. Because I don't want to risk damaging it. But most probably, let's see. This is coming here. Well, no. So at this point, I think I have enough evidence to want to remove the SMC. Let me check. I might want to check if maybe there's a short, but I don't think so. If maybe there's a short on this PP3V0 AVREF something. So nope, doesn't seem to be a short. 530 and no. So I think I'm just going to remove the SMC. So this test I just did with the inductor was useless. I didn't learn anything except that the SMC still seems to be turning on when this inductor is disconnected. Oh well. So let's put this back. Okay. So I'm going to directly remove this this chip. Okay, so now the SMC is removed. Let me connect the board to power again. So now let me show you. So 50 milliamps, not 140 as before. And let me check voltage on PP3V3 G3 hot. Which was right here. Now PP3V3 G3 hot is 3.3 volts. So this confirms that the problem was coming from the SMC or something that the SMC is doing. It's not necessarily the SMC that has a problem. And it confirms that U6903 is working because, and that it was getting hot because the SMC was drawing too much power. So I'm going to put a new SMC. that I pulled from a donor board and that I already reballed. So of course, the problem is that since this comes from a donor board, it's not a new chip. I have no idea if this chip is working as it properly. So there's always a little part of doubt here, but that's the best we can do. Let me put a little flux. This is my new SMC. I do hope that this one is working. And let's try and solder it on. Okay. It seems to be in place. Let's wait a few seconds for the board to cool down and hope that now it is working. Okay. So let me switch views so that we can all see the same thing. Hopla. Oh, okay. So 20 volts. It seems like the board is working. I mean, at least it's turning on. I would have to put it back in the housing to be sure, but this is very promising. So let me reinstall the board, and we're going to make sure together that the device is working again. Okay, the board is installed. I like to put a few screws in order to make it more stable. I don't want it to move. I don't want connectors to get disconnected when I open or close the screen, for example. I want everything to be kind of stable. All right, let's see. Connect it to power. You can see here 20 volts, 1 amp. And yes, it's turning on. We got it. Yep, so let me see. Okay. So this was successful. Let me kind of recap the thought process behind this diagnosis. It was, so I did check the working conditions of the CD3215s of the USB-C controllers. So here, this one, I checked its power conditions. So by making sure that it was passing PPDC and G3 hot, this would guarantee me that this 3v3 LDO, 1.8 LDO-A, 1.8 LDO-D are working. And then the next thing I wanted to check was that the PP3v3 G3 hot was present. And it was not present, it was only at 2.4 volts. This led me to then check why this is 2.4 volts instead of 3.3. So I did check if this chip U6903 that is creating PP3v3 G3 hot, I was checking it, whether it was getting power. It was getting power. Whether it was getting the enable signal. It was getting the enable signal. And then I decided to go to get a thermal image of the board, because my train of thought was that, you know, the board is pulling 140 milliamps. This has to go somewhere, and I'm going to see if something heats up. And so what was heating up? This diode was heating up, U6903 was heating up, but also unexpectedly the SMC was heating up. So I kind of wasted a little time removing this inductor here, because I was expecting that by removing it I would turn off the SMC, but apparently this is not enough to turn it off. Most probably because it was getting PP3V0 from the, where was it? From the U5165, this is enough to kind of turn it on. And so that was a little bit of waste of time. I should have removed it directly, but you know, I don't like to remove chips, like major chips like the SMC, for no reason at all, especially because from experience, they don't fail very often. So anyhow, I should have removed it directly. When removing it, I saw that the 3v3 G3 hot was present normally. And so the next step was to replace it, see if it changes anything. And yeah, by replacing it, the machine turns on. So therefore, conclusion is that this was a very rare case of defective SMC. Very rare, because I've fixed hundreds of these A1706s, and I don't think I've had once a defective SMC. So, I do hope it was interesting, and thank you for watching. See you next time. Bye-bye.